of linear regression. We will do coding and we'll introduce some of the tools to how to do it. Okay. So we will not revise last session today because we might not have enough time, but we will take a survey, and if you feel any of this previous session, some of the I spoke to some of the people and they feel it was little faster. So I'll put up a server, and if you want to revise any of this session, we will do. But based on the survey, we will do. So we'll create a form after this session, and we'll share with you, and you can respond there. So we will revise one or two session, whatever you feel, we'll do that. So now let's start the logistic regression. Okay, so today we are going to cover a logistic regression and how we code that. So let's start. This I have already created one notebook, so we can go through it. But we'll copy paste from here and we'll show you step by step so that we can understand. So what we have to do when you wanted to do some ML programming, you can go to the Google Colab. Okay. So Google Colab is the tool which you can use which we can use to code the ML programming. So it allows you run Python code basically. But what happens? See, this is just editor, but it code won't run in our machine. We have to connect to the Google Cloud hosted machine. So here connect to hosted runtime. This is GC connect to custom VM. So Google Cloud hosted. If I mean this is not useful now, but if you have purchased some machine, good configuration machine, so we can connect to that. Same way, it's connect to local machine. We can connect this Google Colab to our local machine also if we have a Python setup in our machine. But first, here you just need to connect to the hosted runtime. You don't have to see this. You just need to click here. Then what it will do in Google Cloud, it will allocate one machine for you. Okay. So now after connecting this, we are as if this is we have done the TeamViewer, okay, or maybe you just say RDC. So this now we are whatever command we wanted to run here. So we can say if you want to run a Linux command, you can write exclamation dir, and so it will run. So there is only one directory, sample data. Okay, so that can be seen from here. If you click here, this is a directory structure. So right now we are in this. So you can write pwd. So we are inside the slash content, and this is our current directory, right? Inside that there is one folder, sample data. So I think this is clear, right? And this can be saved into our drive. Basically, when you save it, it will save to your email address. It is associated with my email address right now. So I mean, it's just a Google Doc or Google Sheet, similar to that. So this is now there are this runtime. I mean, you can run before. So there are certain commands. We will go through it one by one. So is it clear, right? If anybody has any question, just let me know. Okay. So now we have to do write a Python code. Okay. So what we will do today, we need to import this. Okay. So what is this? What we have done? So this in Python, like I mean, it is just importing, right? So this is we import the three package: pandas, seaborn, and matplotlib. .pyplot. So we just give the name PD, SNS, and plot. Okay. So we will not go through each package, but you can read about this, and we'll go one by one needed. So let me. So what we have to do? We just now we just imported this, so now we can code, but we do not have a data, right? So let us do upload the data. So if I have a data in my machine, and I wanted to put into this hosted machine, right? We just connected. The one more thing is, see, this is not safe actually. I mean, it is possible that Google will, if you don't do anything, it might destroy the machine. So whatever data you save here, it is not being permanent. Okay, so let me, I have one CSV file which I uploaded here now. So now this file will be available here. How can we check that? So you can say the explanation and dir. So we can run a command on a terminal. So see, we see this data.csv file here, right? So now we wanted to load this file. So for loading, we need to use a Panda. So we use the Panda PD as we imported here, and there is one function reads underscore CSV. There are a lot of options actually. So you can go here and type pandas, then you will see documentation. So you have to see all these options. What are the usage? I mean, you can specify the delimiter, a lot of options. Okay, whether header is available, not available. So you can try that and explore yourself. So here we just wanted to, now we need to give the CSV name here and we read it. So what happens? It reads the CSV in memory and store into DEF. So DEF is, it will return a data frame. Okay. So data frame is a class in Panda. Let me search this for you. So you can read about this also. This is very much useful for any programming. Whatever you do, you need to load the data. So there are several ways we can create a data frame. So here this is like we have a column and value. So there are two objects. So this column have a two values and two rows, basically two column and two rows. So that's how you see here. We can load it. We have a data type for each column. We can create different ways actually. So this index is the row ID actually, and data is this data. So this data is specified here as a dictionary. This is a dictionary in the Python. So you can write it like that. So learn little bit about Python. I mean, it's not, you don't need to learn complete Python, but we just need to understand the few things about Python, and then you go learn pandas as much as you can. Then we will see some Seaborn, Matplotlib library and other things. Okay. Then we have to learn the specific tools for the ML. There are three packages like sklearn, scikit-learn library. You need to learn. You need to learn the Keras and or PyTorch. I mean, you start with TensorFlow and Keras, then PyTorch. But for now, and for the time being, in the first half, you don't need a TensorFlow and Keras. This is for the neural network algorithm. What we need for now is sklearn, scikit-learn. So scikit-learn. So this is the website, scikit-learn. Okay. So here there are several algorithm is given, and the type like classification what you wanted to do, which we explained, right? The in machine learning what we perform is a classification or regression in the supervised learning. In unsupervised learning, we do clustering, dimensionality reduction, and like how we select the model and other things. So there are several documentation is available. So you go to the guide here, you can do search and explore a little bit. Okay. So now let me go here. So after loading the data, now we need to see how what is so in this Colab you can write this is a variable of Python. So you just need to write it like this. It will Colab will display it automatically. We don't need to write print. But what the difference between print and this is, if you write some other variable also, it will only take the last variable output. It will remove the other output. Okay. And if you write, if you want to print it and keep it, then you can write this like this. So it will print the same thing. So this df will automatically display. So what is there in this? It is saying a gender. So this data set has a gender, height, and weight. Okay, and the index. So this index is nothing but, see this this data set has index. Index 0 means the person is very weak. I mean, is very thin and weak. Then this is one number is weak. For 0 is extremely weak, 1 is weak, 2 is normal, overweight, obesity, and extremely obesity. Right. So these are the some data set points is given here. So we are just looking at that data, the gender, height, weight, and index. So this data set is clear, right? So the height is given in the centimeter, and weight is in pound. I mean, pound is 2 pound is roughly equal to 1 kg. I mean, it's something 400 and some grams, but for now time being, you understand like that. Okay. So now this data we wanted to plot in the chart so that we can actually understand the, so here you see this is showing rows also, 500 rows and 4 columns. So 4 columns is gender, height, weight, and index, and this 0 and these are actually the table index, row index actually, and these are the IDs. Okay, this is not ID, this is name of the column is index, but this is actually ID. Okay, so there are several so you can, here you go, you can add a new code cell, or you can add a text cell also. Text cell you can write some I mean, you can, and there are some styling you can do. I forget this is markup language, I think. I forget the actual detail of that, but it's a markup language. So you can write has and write test. It will format little bit. I mean, it is saying like this. Okay. So there are it is for heading. You may say I wanted to have 3, so it is third level heading or something. Okay. I mean, you can format your code by this way. And this is the code cell. So now we wanted to see df is our data frame dot info. So I mean, there are several functions. So you go to the data frame and explore it. So this info will show what are the column name and how many null value are there. Not null value are 500, and count is none basically, right? So this is object type, string is object type, so you can gender is a string basically, so that's why it's showing object, but you can cast it to the string also. Then there are these 3 are interpreted as numeric. So all those information you need to, basically it is a table like thing in our relational database, so those things is available. You, of course, you have to practice and explore and read on the internet. Okay, so now let's go here and see what we have done. So this is, we'll do the same thing here. Here, see, what we are doing, we are using a Seaborn library. This is basically built on the Matplotlib itself. That's Plotly is the primary thing in the drawing a chart. So if you run this, it is displaying a chart, right? So this chart is basically a scatter plot. Scatter plot means it will plot a point on X and Y direction. So 2D plot. Here we have a X is a height and Y is a weight. So that's why we are saying that we will pass, this is our data frame. Data, you can pass entire data set, data frame. So now we just need to specify the column name. This library knows that I have to pick the height column of this data frame. So you can pass data frame here and you give the name of the column here. So we are saying the X column is a height, Y is a weight column, and these columns are available in this data frame df. So we specify the data frame, we specify the x, y, and we say hue means the color, right? So we are saying the for color use this column values. So there are 5 different classes, so it choose the 5 different colors actually, and we are able to see those type of point. So here is red is a 0, is basically extremely weak, right? Then this is this golden color is weak. Then how do I know which one is which? Is basically this is labeled right here 0 and 1 2 3, and we know the here the we have number 0 is what, right? So this is our data set. So based on data set, we are able to say that this is what it is. Now this blue is the extremely obesity, right? So what we will do, we will not classify for the time being. We wanted to just classify in 2, obese or not obese. Okay. So what we can do, let me explain this also. Rest of the parameter. So this hue, color, this 3 4 parameter you understand. Then this is a palette. If I don't pass this, then what will happen? It will give some default color palette. So it is like it is taking this default by default set palette. So it was not looking good. So I just choose some other palette. And how do you know which palette are there? Then you just search just for palette and SNS or Seaborn. I mean, you have to write Seaborn, but SNS most all people use, so it will give. So you go here and look for different colors. So these are the color palette, different color palette. I mean, you just need to search on the net, and there are a lot of materials you can get. You just need to type what we wanted to do. Okay. So this, if you wanted to use this, then you can use that also. Okay. So this change basically, right? Okay. So we'll go back to what was there. So I think we know how to plot this scatter plot, right? So here this is this how this point is plotted on the chart. I mean, everybody knows, but see this point is what this point indicates. This golden point is saying that the height of the person is here, so it is maybe 168, and the weight of the person is 45 or something, right? Basically this side. So that's how this draw the point, and that's how we get the groups and other things, right? Okay. So now let me skip this for a while. So what we do, I just tell you that we wanted to make this only two group. Okay, so two group, how we will do? We will say the phi is obese and below phi is not obese. Okay, so we just we take the extreme obesity as obese and rest are not obese. Okay, we wanted to find, I mean, basically who needs a treatment, or maybe something needs to be done, so needs to be done something about the obesity. So let's say we just wanted to, we create a column. So if you wanted to create one more column, it's very easy. You say data frame, you type the column name here, so it will create a new column and you assign the value. So how we can assign the value? So this is index and this is numeric value, so we are saying greater than 4, so it will return for all of these rows true or false. Okay, and this will be with this index also, so it will match the index and assign into data frame. So after that, you see this data frame, this is displaying for, this is for displaying the data frame, right? So we see gender, height, weight, index and obese, right? So we see this extra column which is obese, we just created obese, and there is a value false and true. So now we will not use for our training this index, but we will use the obese as a, so now we display the data again in two color. So this color in hue, what we set earlier on, we set index, now we are setting obese, right? So rest are same, we provided the same data frame, we use the height, we use the weight, but we didn't use the index. Instead of index, we use the newly created column which is obese, and we use some color palette and we just say so this is showing false and true. So now we wanted to learn border in between, we wanted to separate this by looking at, we can say that because we are looking at, but if you wanted to have separator here, let me, then we need to run some machine learning algorithm, right? So that is we will do it by using linear regression. Okay, why linear regression? Because these data set are linearly separable. I mean, you can put one line in between and this can be separable, right? So what we will do, let us use, we will not use the, here what we use two feature, right? Height and weight and obese. So what we have to predict is, if you have given height and weight of the person, will you able to say this person is obese or not? Okay, so that's we need to, I mean, it's a very simple example, but I am taking it because you all will, we all will understand it. Okay, so this is obese, or so what we will do, we will not, for the understanding, we'll use, we'll predict whether the person is obese or not just using weight. Okay, so I draw the weight and here obese or not obese. So if it is obese, it will 0, and if it is sorry, if it is not obese, it is 0, and it is obese, then it is 1. So the plot will look like this. If everybody understand that, this is very crucial. I mean, if not, then please let me know in the chat. Okay, if you are understanding it, write yes. Okay, so few people say yes. Okay, okay, so this is just because we have only height and the y-axis is obese. So we say the person weight is something 60, then we'll plot a dot here and it is not obese. So there are some range right here. This range, we are not able to say person is may be or may not be in this range. Let me, Okay. Somebody has drawn. Let me clear this. Okay. So see, in this range, if the person's weight is above this, here you are 100% able to say that this person is obese, right? This range is also clear where we can say this person is not obese. So here we predict 0, here we predict 1. If you write a function and put just condition, if condition, this both side, and you know this range, then you can do it. But we can't do for this particular range. We are not able to we are not able to clearly say that whether this is which side. So what we have to do, we may fix, if we remember the linear regression, if last time what we see is the linear regression, what we can do, we can fit a line like this, right? If we do that, what happens? Up to here, here also, let's say this is a, we consider this as a probability, okay? Probability is between 0 to 1, right? So if we say it will predict 0.20% probability, means it is being obese, but we are sure that it is much higher, that it is not obese actually. Here, if in this side you say this is obese, and then you say 80% obese here, but we actually we know that in this part it is near to 100%, right? Very less chance of. So if we fit this line linear regression here, it will not give very accurate result. So instead of this, what we have to do, which one we should do? We can fit line like this, right? So we say we are sure, sure, sure. Up to here we are sure. From here we are not sure, and we say from here like this, right? I mean, I have just drawn little bit like this, right? This is more appropriate, right? This function is, instead of this one is good, right? So let me show you that also. So I have kept it here. So this is I'm trying to draw. So this is the function which we wanted to learn. Okay, if we have this function, then what we can say, see here we can say the probability is 0.5. We don't know whether in which side it will go, here or there, but not here actually, but we might need to fit that. I mean, somewhere we don't know where actually it will locate. It might locate here also. Okay, so we will learn this. Okay, how we learn, we'll just explain that. So here we are saying we are maximum unsure. That means the probability should be 0.5. It may be or may not be. I mean, it go anywhere. So it is like random, completely random. We can't say anything about that. So that's why when we can't say anything about that variable, it is 0.5. Okay, the probability of that is 0.5. So that's why then we are able to say that, yeah, this is leaning toward the not obese or obese. So that's how we use this for classification. This is the, now we need to learn which function it is. Okay, so let me show you that. Not this. Okay, so this is the function. Okay, I explained this in the our earlier lecture, but let me describe here. Duplicate it. So y is equal to mx plus c, right? So m is some value. So we say, let's say, instead of saying m, we put the m value something, and we put y, say some value, let's say pi. So this is a line value, right? If we put 0, then it will pass through 0. So we understood this from that. Now this is a linear regression we show, right? Now we wanted to do that other function. So what we can do, the function is sigmoid function. So somebody has figured out for us. So let me write it, the formula of that. So e raised to minus just a second, e raised to minus x. So this is the function. Its lower value is 0. It at infinite, negative infinity, it will reach to 0, and positive infinity, it will be 1. That means it will always between 0 and 1. It never touches to 0 and 1. So here you see the graph is like 0 to 2 here. So this is 1, right? Here it is 1, right? And this will never touch here. I mean, we can't see it. I mean, it looks like it is touching the line, but it will never touch, because it will touch where? It will touch at infinity, my negative infinity, and this is at positive infinity. It will touch the 1. So let's say this gives us a probability. Now the shape of this is very, I mean, we might need a steep, or we wanted to change it. We want to play with this shape. How we can play? So here, instead of x, what we are saying, it's the same thing. It's the same thing, like we can put some value here, and this is our, so we can play with it. So if I add this like 10, it will shift. Okay, so this is interceptor, which we wanted to learn, where we wanted to fit. Okay, so if you change the value of this, it will, now I put 77, so it will be at far. See, you see here, right? But here the x-axis is large value, and our y-axis will not cross 1. So you are seeing very tiny here. Here we are seeing the just a tiny slope here. Let's say for explanation, I'll multiply with 100 here. So I mean, for scale, so we can see that also. So it will go up to 100. Let me, so see, now it is very steep, right? So we can change this slope. Let's say we put it to 1, then it will look like this. We can put 0.5. So it changes, basically the shape will change. You put 1, it will have a different shape. Something happened to this graph. Okay. Okay, so this is like this value. We wanted to learn these two things. Okay, this is our coefficient for weight. Let's say x is our weight. We say we multiply with something, and we get this value, and this is our interceptor. in our linear regression, right? So linear regression, what we were learning, we learning these two value. So we'll see. I'm just explaining it. It might difficult to understand for a while for some people, but it's okay. Okay, so I think you are able to see these values. So we basically we instead of this we will say this is theta uh, theta 1 and this is theta 0. Okay, this is theta 0. So we will learn these two parameter by using algorithm. Uh, and what is the idea behind this? Basically, this see this is a sigmoid. So we'll use the sigmoid function, which will give us like a curve like this. We are able to play with the shape of the curve, and the position of the curve. So we don't know what data and where it will fit, but the fitting of the curve we will learn from the data. So how we can do it? Let me show you that. Okay, so now we'll come back here. We just explained a little bit what we are doing. What is logistic regression? So this learning and finding that curve, a sigmoid curve in this data is a logistic regression. Okay. So how we can do it? So first of all, if we do uh, the fitting of the curve, we also need to test for the real data, right? I mean, how it will work on the when you fit, it will fit 100%. I mean, most of the cases, but how you will check that whether it will predict the right value in future also. So what we are doing, we are dividing our data set. Data set has a 500 records. We are dividing it to two part. I have taken it here less than 160 because see if I'll explain this also. If I don't do this, then the data in data set are height weight is up to here. So it was for explanation it is not good, but real situation there is no issue. But for I wanted to explain to you, so I just have to have both the side. But if I keep then right side there is no data. So what I decided to, I'll not consider the persons which are having a height more than 160. Okay, so I'm limiting my data set. Once I do that, then I have this many points. Okay, now here see by doing this I'm creating a new data set here, and I can ds dot shape. There is one shape. Okay, shape will give the dimension of data. So it's saying ds has 151 rows and 5 columns. So after removing this greater than 160, we only have 151 record. So this will create a data set, a filtered data set. Basically, we have selected some row from a table, something like that. So how we select? We put the where clause, height is less than 160, and it will return a true false. So this will apply to the index wherever it is true, it will pick that particular row and it will assign to dataset, and the dataset what shape will give the number of records. Or if you want to see the dataset itself, then you can say like this. It will show the selected rows where you will not find the height which is greater than 160. Only person having height below 160. Okay, so this is okay. Now what we will do, we will, so let me change this how it was. Okay, it is there. Undo. Okay, so then this is okay, this is okay. So yeah, so let us do this. So here this function I explained this two line. I need to import this sklearn scikit-learn has model selection package. Inside that there is a train, test and split. So it will divide our data set in a two part, train and test. Okay, so for that we use this function. What this function requires is it requires two data set, x and y. So x is the training and y is the label. And we are saying that what should be the test size. So we are saying 0.33 is the test size we want. So 30% data keep for testing and rest should be in training. And here random state is basically they will pick the sample randomly from the data set. So they will pick for train and test they basically this state. So you change this state, the randomness will change, data will change, but it will pick randomly. But from the this is basically a random seed. It's not me, I mean it just consider for now it you get the random data selection. So it's not that first 33 will come in here. So this is split the data randomly. So now it will we pass two data from here, two data from here, and we get a 4 out of here. So it splits basically in train and test. So that's how we have to write it like this. And we get the all of the shape. If you see the shape here, we have a training, we have a 101 data point. For training, we have a 50 data point. Sorry, training we have a 101 and testing we have a 50 data point. So that's how we are just seeing the shape. Shape will give this is the first dimension, this is the second dimension. So this is rows, columns. In some of this in data frame it is okay, but if it is NumPy there may be a multi-dimension also. But right now this is okay. So now after now we have prepared our data set by using just one single line, train, test and split. We have a data set, we pass it and we say divide it in two. Before that, here there are two things, right? What we have done here is saying that x, what we are using in data set, just select the one column. Okay, so we use only first column. So you can give the array of the column. If you don't give this array, it will return the series, which is just a column, but it is not a data frame. But if you put this double curly braces, it will give you data frame here. So x is a data frame, y is a series, panda series. Okay, we wanted to have x must be the data frame, x must be a tabular structure, because this requires it. I mean if you give that one, then it might not work when we fit the model, because it may have multiple dimensions. So we have to pass the in a 151 row and one column like this. Otherwise it will come up like this. See, series have only one dimension, this has a two dimension, the other dimension is only one dimension, but still there are 101 and 1, and here you see only 1101 and comma, you don't see any other value, because this has only this is series, that's why basically it is list and that is a table. Okay, this is list and this is table. Okay, so I think this is everybody can understand this, right? If not, please ask, unmute your microphone and ask. I will explain up to here. Any question? No question. So here now this is scikit-learn library, linear model and logistic regression. So this is the machine learning model which we are going to use. So how we can use, we just need to define that classifier here, logistic regression as a classifier. So we created the model object here, and then all this model have a two method. One is fit, another one is predict. Okay, fit and predict. So first we fit. So when we fit, it will do the mathematics behind it, what we are trying to explain, how to feed the curve and other thing. Okay, so after that we get two things in linear regression. We get these two, intercept and coefficient. So let me run for you. It will get, we get this value, right, minus 15 and 0.177. so how is this curve is fitted here? So this was our data. Okay, now we see how we get this value. So if you put it here, the value, exact value, uh, where it is. Okay, here. Yeah. So the intercept is what? This is intercept. If you wanted to print two value, then you have to write in single line. I just told you, right? If you write two variable, it will override. But if you write in one line, it won't. It will give the comma separated value like this. So here, uh, minus 15 is the interceptor value. Okay, and 117. Okay, let me copy this too. So over here, and we put it here. So our equation, we create y is equal to 1 plus e raised to negative in bracket negative 15 point something 0, let's say, and x plus, sorry, plus negative. So we write negative 15 because this is interceptor. 15 was the interceptor. This is 0 0 point, and this is a positive value 0.177. Should create. Okay, so it is because this value is very slow. So now, yeah. So now see, let me reset it, and I have a zoom here. Let me say. Okay, let me say. Okay, see. So this is the curve which we fit. Okay. This is the curve we fit. So how we match, how we see what is this curve? We need to match with this value. Okay. So if you see this graph, it is saying at 90. Okay. This 90, let me, at 90, it is below, right? Here. So let me show you this. So here from 70, I think it is 60, right? 20, 40, 60, 80 and 100, right? So at 60, up to 60, it is near to 1. Then it's little bit high. and 0.80% when it is 80. Okay, so if you go here in this graph, see up to 80 is 0.80% it is giving. So this is the best curve it thinks it is found. So let me draw it here. So it says up to 60 it is almost 1, then it start to increase little bit up to 80. So 80, when it reached 80, it gives a 20% of the accuracy, and then it says I need to check what the value at the right side, but this is how some curve it figure out. Okay, so it goes where it goes at 120, 110 actually, 110 it touches the 1. Okay, so here 110, yeah, I mean it is same. So this is how it figure out some curve, and this is the best curve which gives probability structure. So what that mean is basically, if you are here, it will say probability is very 0.5. If you are from this side, it will always say not obvious, not obvious, not obvious. From here, this will say obvious, obvious, obvious. But it will give a less probability up to 110. It gives a little less, or maybe say 100, just 100. It gives 80% chance that it is obese, and here 80% chance, 20 is 1 minus 20 is 80% chance not obese. Okay, 20% chance of obese. So that's how I'm saying when it is 20 it is 80, because it's 1 minus 20, so it is 0.8. So hope this is clear to everybody. Say yes if it is clear.
Yes, sir. So I have
Okay.
other question, Sumit here,
Yeah,
sir.
yeah, go ahead.
I'm not sure. I guess you would have already taught it. I might have missed it. But so how do we decide which model will be best for this data? Like we have chosen logistic regression, right? There are lots of linear regression models. So how can we identify that? Like we should use logistic, or we should use Byzantine, or Lasso, or any other?
Yeah, so this see lasso and other lasso, ridge, lasso, and elastic is the regularization method. We didn't cover in the session, but
Mhm.
it is a logistic regression, and you do little bit of cost function. You add some penalty, and it changes little bit. But it is will come to that. But this is overfitting and underfitting. When your model is
Mhm.
overfitting, we need to regularize the model. So that is okay. But the main is, see, in machine learning we have divided 3 type, right? Supervised, unsupervised, and reinforcement learning. Okay, supervised
Yes.
learning, what kind of task we can perform? We can perform classification, and we can perform the regression. Regression is what? When we wanted to predict a value which is numerical value. Let's say we wanted to predict the price of something. Okay, or
Mhm.
length of something, then we predict the, if we wanted to predict the height of the person in this case, then we should have used the linear regression. Okay,
Mm.
but this logistic regression is named as regression, but it is a classification. Okay, here what we are doing classifying. We are saying
Classic.
whether the person is obese or not. So our output is 0 or 1, right? I mean, we are
Yes.
predicting probability. Always we
Mhm.
predict the probability, but our label is what? Label is 1, 2, 3, 4, 5 earlier. Then we change it to greater than 4 or less than 4. So that means 0, false, and true and false, right? Person is obese or not obese. So that's how we train our model in our data set. See here, true and false, right? This is
Yes.
our prediction. So this is our label column, and this is our input column. So false and true. So this is a class, right? I mean, it is only two class, right? Two value are there. It is not continuous value. It is not a variable integer value, right? It's not continuous value. I mean, it's not continuous also, and it is not something. I mean, it's not numeric value, right? It's a class value.
Correct, sir.
You understand, right?
Yeah, yes.
Basically, categorical value, and that is
Correct.
numerical value. So when it is categorical, we have a few choices. Algorithm which are able to classify. Okay. So classification algorithm. I have given one table also in the last lecture. There is it listed which. So first is linear regression. That is the first model which we should try. This is simple and straightforward. If your data, let me say. Good question actually, and it helps everybody. So let me. So let's say these are some point, okay? And let me change the color. And these are some different class. Okay. So if we use the linear regression here, it will not give a good result because it is very much mixed, right? I mean, data is very much mixed. I mean, you can't separate this, right? Completely. So you can't use. I mean, this is very difficult for some of the algorithm also. But if we can add some feature, we might need to add some feature engineering here. If we add some feature here, let's say this is 2 dimension. Instead of we create one third dimension, where what we do, we move the yellow dot little higher than the black dot, then we can segregate between this. So I mean, this is a feature engineering I'm telling it, but let's forget that. So what is the ideal for linear regression is if your data is like this, there are some data point here, and let me change the color, and some data point are here, then this is the linear regression because it's linearly separable, right?
Yes, sir.
Maybe some data pointed here, but few must be there. I mean, it is not, you will not find the accurate, but there may be some data point, right? So if you have some data point here, like this also, then this is a exploratory data analysis, and you have to remove this data point because these are outliers, which is maybe by mistake somebody has put this data. So we need to, how we understand that? That's why I show you the scatter plot, by which we have to understand the data first from the scatter plot. Okay. So that's how here we are able to see that this data, after doing this two classification, this red and golden, we need to separate, right? So this is, it looks like it is linearly separable, right?
Yes.
And hence we use the logistic regression. So other one is tree based structure. I mean, tree classifier, gradient boosting tree classifier, and random forest. So several algorithm are there. So every other algorithm are named as classifier. The exception is logistic regression. Still, it is a classifying algorithm, but name is linear logistic regression. So there are some history also, but let's forget it. Just try to remember this is not. It will want it. It is a classifying algorithm, not the regression algorithm, even if the name contains regression.
So data is linear, and we are doing classifying here. That's why, and for the classification,
data is linearly separable. See, data is not linear. Data is linearly separable, right?
Yes.
So I mean, it is not. It should not be exactly linear. Also, I mean, it could be here, a little bit here. That is also linearly. When you do a polynomial regression, then also you can do it. Let me say, you can see even you can feed this type of curve also. Okay, but it is more or less it is in line. It just there are some curves, right? How we can do this? I mean, it is little bit. We need to do the feature engineering. and we say polynomial feature. Feature engineering is what? We have a two feature, x1 and x2. Okay. What we can do, we can create one more feature. How we can create? We can say we will put the x square value also. So this is a new feature. We just engineered using the same feature. We can write like this also, x1 into x2. This is also a new feature. We can say x square is a new feature. So there is no limit. I mean x square. Then you say x cube, x4, x. I mean whatever number of you can create. It's not just that. This is, you can just say 1 upon x1. I mean anything, whatever you is impeccable to your y. Okay. So how we decide that for the linear regression? I skipped actually initially because I thought it is too much of mathematics and people get bored. So I didn't use, but let me explain that. So I skipped this chart, right? So this is a correlation. So what is
Yes.
correlation? Correlation is basically if you calculate the covariance. Covary means what? Let me explain that. So let's say this is our x, okay, and this is our y. Okay, let's consider the 1 point. Okay, so let's say this is the point. Okay, now I mean the x value is this, y value is this, right? That's how um, we see the point, right? So the some value, let's say this is 1 to 100, and let's say this is 1 to 100. Okay, so now if I take x value here, okay, then if my y value is goes here, so point will be here, and if I take the another point here and it still increase little bit y, right? So that what that mean? If I increase little bit in x, it increase in y. So that means it is, there are some correlation. If I increase x, my y is also increasing. Okay. Then that means there is a correlation. Okay. It's not that if it always it should increase. It may be decrease also. Then also it is correlation, but it is negative correlation. That means if I increase bit in x, my y always decrease. Okay. Then that is a correlation. So if that is how we calculate it by covariance. What is covariance? Okay, let me explain. So you need to understand what is variance. So variance is nothing but, I think I have somewhere. Let me search here. So covariance is nothing but x minus, you take the mean and you subtract it. So from all value, so you get some value, the change in the direction, right, from mean. So we are considering I pick the 1 point, right? Instead of picking 1 point, we say the mean of that value. How, I mean it's variance. If you know, this is like you need to understand the variance. Then x minus x bar is the mean and y minus y bar is the other variable mean. We multiply it to, why we do that, and we sum it for all point, and we get one figure, that is covariance. Okay, and then this value will not be 0 to 1, so we have to keep into 0 to 1. So when we divide by standard deviation, it gets the correlation. It's just normalizing the value actually. So this is the formula of r square. So this is relationship, and then we get the correlation. So how we get, we don't need to learn this function, so we just need to use this function, the data frame dot correlation. Okay, so data frame dot correlation, when we do, we get the correlation of all. There are 3 columns, so that's why each column is representing x-axis and y-axis. So what is saying, height, height, let's say this height versus height is 1, because always whatever is happening with one value will be because it's the same value, right? So it will always be in with synchronized, right? So that's why it's 1. So diagonal, the heat map diagonal, correlation diagonal will always be 1. So that's why it's 1. Now we say what is the correlation between weight and height? If person's height is, see, this is the positive value. That means, I mean, there are little, actually it's near to 0. That means there is no correlation actually. But if you, there are little bit which says the if height increase, it is little weight is increasing, but this should be considered as 0. And so that means there is no correlation. That means height and weight are independent. So we can't predict by using height, we can't predict weight. By using weight, we can't predict the height. Okay, so this gives a
Yes.
predictability. So same way, index. So if you see the index is 0 to like obvious. I mean, there are 5, 6 steps, right? So it is saying 0.42 negative. That means if your height increase, with response to, with respect to height, let me. So this height and this index, this value is
Increasing.
negative 0.42. That means it is negatively correlated. So if you are your height is more, then it less likely you are obese. Okay. So that's what from our data based on our data. Okay. Now if you see the weight column, there are correlation value with index is 0.8. That means the weight is highly correlated to the obesity and positive direction. So weight increase, you are, it's more likely the obese. I mean, we all know, right? So that's the measurement of the weight actually. So that is showing here. So now which column is more predictable? You can just guess from here, is the weight then the height, right?
Yes.
But is, I mean, says if you take the combination, it will give you something else. But so we have to use whatever power it is, and we have to try also. We can leave few feature, we can try add other feature, all that we have to do. But from beginning, let's say this is so I choose the weight to predict the index. Okay. And for understanding, I wanted to have only one variable, but we can use 2 variable also. So I'll show how we can use that. So here what we did, we just see the linearly separable, and we use this function, we predicted that, and we get this 2 value, right? We get only one value in array. We have one value, and one is, this is interceptor, basically the position of the curve, and this is the coefficient. So coefficient is the, if you have a weight, you multiply by 0.17 and you add this 15 and you power the e raised to x, you will get the probability. Okay, that is what the function which we are trying to write, right? How we formulate the probability is p probability of x at x is equal to e raised to negative in bracket theta 0 is interceptor plus theta 1 and x. So this x is our, in our case, weight. Okay, and not just exponential, 1 upon 1 plus, I forgot this. Okay, so this is actually probability equal to sigmoid function 1 upon 1 plus e raised to negative theta 0 plus theta 1 x. So this is what it is, our curve probability distribution. So if you put the value of weight here, and you use this theta 1 and theta 0 from this value, we will get the perfect classification. Okay.
Okay.
Okay, so anybody else any question? Or anybody? Okay, so I think we will not take break, right? Or we should continue. I think we are all at home, so we'll finish this. Okay. So hope it is clear now. So after training, what we learn is we learn this two theta 1 and theta 0, and we can see this score also. Okay. This score gives accuracy. I'll explain what is accuracy and other things, but let's for now, it gives the 90% accuracy in the training and 98% accuracy into the test, because we have a very limited data set and it is predicting by chance we are getting good accuracy in testing. So and let's say we wanted to predict, then that's how we can predict for the new data set. You give some and you get the y value here. Okay, so what is y will give you the probability. So y will give you these I mean sorry, true and false for each data point which are in this x. So okay, so this is series, so we have some value. Okay, I mean I can pass some value here also. This was I'm trying to show you how we can pass pd dot series. You can give some value here. This is weight value, so you can predict you will get a 2. Expected 2D got 1D instead. That's what I'm thinking, but why X test data frame? Okay, it is data frame. Okay. So we can. So this is one more library. Okay. So you can create an array where we don't have a column name and something. We just need to pass some values. So we can install this NumPy. NumPy also you go and read about it. So we can specify create array like this, and we wanted to create array like this. So I will create this to pass to me over here. I can use Panda series also. I need to pass the data frame here, but instead of data frame, what I will do, I will pass 200. So for if weight is 100, it should say not obese, right? I don't have an NP here. I need to import. Okay, so this is true because 100 is also our algorithm predicts for 100 also it is obvious. So let me put some less value. See, now it is false and true, right? So this is easy. Basically, we just need to calculate that. Okay, so this is prediction. Now, this is accuracy. I'll explain what is accuracy. I'll explain the confusion metric also. So this is a confusion metric. So confusion metric is what? This is actual value and this is prediction. Okay. So actual, there are two class, obvious or not obvious. Okay. So in obvious, there are 35 value, right? I mean, for this, we are just showing the which data we use. We are using a test data set. So that's why only 35. Okay. So in testing, we have 1 and 34. So that's why actually there are 35 point which are obvious, and actually there are 15 plus 0 is 15 point which are not obvious. Okay. Now in prediction, what we are saying, we are predicting 15 plus 1, 16 point as not obvious, and we are predicting 34 point as obvious. Okay. Instead of this, let me change. Let me remove this. I mean, I'm using all values, so it will give some different curve.
You have changed the Y predict to the sample value.
I change that.
Yeah, the Y predict is not being assigned.
So Y period. Okay, I change this. Okay. I need to predict this. Okay, now it will print. Okay, so now we have number. So what is actual is basically it's saying obvious there are 13 plus 51. So in data set there are 64 obvious and 101. 89 plus 12 is 101. So 101 not obvious. Okay, this is understood. Now you can see. Then predict what we are doing. We are predicting 102 as not obvious and 63 as obvious. So what that means? So this is the 89 were obvious and they are predicted as obvious. So this is a true. Basically, this not obvious if you consider the true false, right? I mean, so this is originally it is not obvious, and our algorithm also saying they are not obvious. But in this case, there are 13 obvious, but algorithm is saying they are not obvious. So these are the false basically. Okay, and this is uh, so you can say this is true, this is false, this is true, right? And this is positive, this is negative, negative, and this is positive, right? So if you say positive, so this is a false negative. Sorry, this is okay. So we have to set the context actually. In which context we are saying. So let me understand. So false negative. Yeah. So this is false negative. False because why false? Actually, it is a false, and we predicted negative. So this is false negative. No, sorry, true negative. Sorry, this is true negative. It is confusing, and I am also always get confused because why it is true? If you consider this is not obvious, right? And it is. Let me see. Okay. I forget. Fusion. So I just so it is like this. Okay, so here it is actual value is above side, and the predicted value is this side. Okay, so what I am trying to say is actually what is that is true or false. Okay, what in reality, if it is true, then it is true. So let me put it like this way. So here, so this is truth, right? This is not obvious, and it is not obvious, right? I mean, this is from actually it is what this not obvious is not obvious, and this is actually it is obvious, and we have um, I need to understand again. Positive, positive. Okay, let me explain now. So let us consider from the prediction side. Okay, this prediction, we say how it is predicted. This is predicted as positive or negative. So let's say this is predicted is negative, right? This is negative, right? Why negative? Because it's not obvious. Not obvious is negative, and obvious is positive. So it is predicted as positive. It is predicted as positive. Now we have to see what is actually it is. Okay. So this is true.
True.
Right? This is false.
False.
And this is true because it is true, and this is false, right? So that's how it is. I just confused because I trying to from actual. So we have to go. The positive word comes from the prediction, positive and negative, and the true comes from the actual. Okay, so that's how we put. So it is understood now, everybody. I think I have to explain again if you want, and it is always confusing for me. Is this clear, everybody?
Yeah, that's it.
Okay. So now what we are trying to say, we are saying that we have predicted the accuracy is what? So we have to count the false, and we have to count the true, right? So if we accuracy is basically if you add 89 plus 51 and total, okay. So 81 plus 51 is what? Is 140, right? So 140 divided by this total. Total is how many? Let me go and check. So total,
150.
I can, we just need to 500, right? No, 500, not 500, but dx underscore test dot shape. It will give the number. So 165, right? So if we do 140 divided by 165, it will give you the score 84. So if you calculate this score for test, it will give that. Okay, so this is accuracy. So now you understand what is accuracy. Okay, now there are three more terms. One is precision, one is specificity, one is recall. So sensitivity and specificity, there are two words. The other two is precision and recall. So we use precision and recall in the machine learning, but what it is actually. So if how precision, what is the precision means, if whatever number you are predicting, so that means 89 and 13, right? So this is like whatever in context, if you add this two, and how many of them are correct, this not obvious. If you say the what is the sensitivity of this test, obvious or not, then how we can calculate is 12 plus 51. Okay, because if you consider the obvious as the positive, then 63 out of 63, total are 63 and 51 is correct. So 51 upon 63 will give you a precision. Okay. And recall is what? Is basically this obvious. Okay, so how many obvious were there actually, and how many are predicted as obvious? So there are total obvious in this direction. If you see the horizontal, there are 64 obvious are there. Okay, and out of 64, there are 51 was predicted as obvious. So this is a recall ratio. Okay, this 13 will not been classified as obvious. So that's how when you say recall, you have to see the horizontal line, in this case actual side, and when you calculate the precision, so I mean you have to look at the formula. There are formulas in this recall and precision. So in Wikipedia also there are a lot of formulas. So this is basically explanation is also given there, and this what is positive. This accuracy is what we just saw, true, and then total, right? So this is what we calculated. Then precision is true positive upon true positive plus false positive. So basically all positive. And out of all, how many are true positive? So that's what I was trying to explain by the true positive is
64.
Yeah, and true positive is what? It's 51 and total positive. So this total positive is 63. So 51 upon 63 will give you the recall precision. And this is recall 64. If you divide 51 divided by 64, you will get the recall. If you see this formula, I mean, you go and look at it, and it's true positive. And so we have to label it again. How we label it? We label it like this, right? So this is our labels, true positive. How we did it? Let me do it again. So the prediction side, this is positive. We predicted this as positive. We predicted this as positive, right? This line, because obvious is positive. This is negative. We predicted this as negative. We predicted this is negative. Okay. Now what is true and what is false? This is true, right? This is negatively and it is negative. This is positive and it is positive. This is predicted positive and actually it is positive. This is predicted as negative and it is actually negative. And this is a predicted as negative, but it is positive. So it is false negative. And this is predicted as positive, but it was
False positive.
So that's how we get. Now, now this count is there. Now you just need to see this formula. You put this, then you'll get this. So this formula is what? Precision is TP upon TP plus FP, right? So let's go back here. So TP, so this is 51 upon TP and FP, right? So this was I'm saying 51 upon 63 will give the precision, and recall is this 51 upon 64 maybe. Just see. See, in the context of obese, I mean, you can calculate for other not obese also. I mean, true negative rate, true positive rate, true negative rate is this. So same. So now let's say there are two terms actually: sensitivity and specificity. So we are saying this person is very sensitive, right? That means what? I mean, he's in a positive. He generates more positive. Okay, he predicts more. It is leaning toward the positive side. So it if somebody, let's say the person is a security person and he is very sensitive. So if somebody comes and asks something and explain him, he will allow him to go. So it is very sensitive. I mean, he will listen to somebody and take the exception that he will say, I mean, nobody should punish. His approach is that, like our law, I mean, nobody should get the reason. I mean, if even if one person should not get punished without having his crime, if 100 will live free, this is okay, right? So that's a philosophy when you are very sensitive. And very the specificity is what you are very specific. I mean, you say that if I don't care, I mean, you whatever you are maybe right, but I will not allow you to go because you are very specific. Whatever is required is required. I mean, I don't listen anything. So that is very specificity. So these two terms will come and required. So then there are F1 score and a lot of things because when we train the model, right now it is too much. So we'll not go inside that now. Let's go back and complete. I think we reach lot of time. Okay, so what we did here, this is a classification report. So you can print just the classification report, you get all those things. Okay, so you get a false for false. This is the precision, this is the recall, and this is F1 score. And accuracy is what 98% and other things. So if you calculate, it will give you this all, right? Precision, recall, and other things, 84, 85. So you try this classification also. Then we are using now, we use only weight initially. Now we will use the weight and height, both the picture. Okay, so for that we put the in X we put two things, weight and height, and Y is what our the obese feature, and we split the column. So and we also created one object of logistic regression, and if we put the fit also, so we get the classifier. It is always a fit function always return the classifier, so I can write it like this also. And then we predict that, and we see the classification report. So see, this classification report is improved a lot, right? So it is for testing, it is giving 96% accuracy, precision for false, and 98. So accuracy is 97%, right? And if you see this diagram, only 1 and 4 are for test data set, very less false. Then we can see this how our data is separated and which are false and which are what. So there is a function in the inspection of sklearn. So decision display, we need to pass the data and some label to that. So it will calculate, and we need to scatter plot on this. So if you don't do this, then you will not see this dot. You will just see the boundary. But if you wanted to see the data also, then we do the scatter plot on this also. So that's how we get this. So this is the boundary we learn this line using this fit function, and we see this is wrong side. So this is classify one wrong, right? Here this is one wrong, is this one wrong, and there are 3 4 here, 4 actually, yellow color dot which are residing in the other side. So these 4 are this. So that's how we can just view our data. I mean, if data is very large, it is not useful, but to understand something, it is there. So that's how when we use two function, how we can do, what we get is basically we get two parameter, theta1 and theta2. How we can see that? Let me. So classification. So our classifier name for 2 is 2, right? So we'll use this 2 and we'll print this. It will give one intercept. Interceptor always be 1, and the classifier value is 2. So how with this, how we formulate our function if probability is, the probability is equal to 1 upon 1 plus e raised to negative in bracket
theta1
theta 0 is our intercept plus theta 1 and this is a weight or height, so we say x1, okay, and we say theta 2, sorry, this is plus, and x2. Okay, so x1 and x2 is what? Height and width. So in our case, the 0.8, this must be the, which one must be what? 0.57 and negative 0.8, right? So how you can know is basically, see, this is negatively correlated, right? When you are obese, so negatively correlated is basically what is height, right?
Yes.
So this is height and this is weight. So if you sum these two value and use this formula and calculate, then this value we don't know initially, right? So what we did basically, we learn this 3.3 theta. Okay, by using the speed function, we'll give you this 3 function. Now, if you wanted to integrate in our prediction, we just need this 3 value, nothing else. And there's formula. You put in your formula, you can predict it. So logistic regression is very easy. I mean, for prediction, I mean, you just say you have some application and we wanted to integrate there. We just need this 3 theta, right? So this is all. So now let me come up to the Janmajay, and what we have done here is basically we created one competition. Okay, Argus bike renting for regression. So this is a regression problem. So you have to use the linear regression or SGD regressor. You can use to do this. Okay, and this there are some description are given. So this is data. So data is basically there are some columns. What columns are there? Okay, columns. Okay, so this is the description. So some of the column have been removed, which are not useful. Okay, so what you have to predict? You have to predict the count. Okay, so data set has different values, columns, many columns. The which year, month, and week, day, weekday. So means Monday, Tuesday, working day. That day is working day or not, and weather list. Weather is clear or some. There are some options, right? So rainy or what? There are heavy rain or all other things. So if the weather is bad, That means people will not go out, and if they don't go out, there is very likely that they will not hire the bike. So this is like a renting agency. They give the bike on rent, and they wanted to forecast their demand, okay, every day. So you have to calculate that based on this data. So they have a data actual for actual data demand, what happened on that day. So they had a humidity also and their wind speed also. If wind is very high, then obviously people will not hire more bike, right? But we don't know how it is going. So you have to do this data exploratory data analysis, and then train a linear model which will predict the count, okay. And once you, there are two data set, I think. Janmajay, can you explain that?
Sure. So what we have here is a data set created by one university. It's they have two data sets. One is by day and one is by hour. We are going to use the data by hour. So what you have to do is we have some training data set which takes every month for first to 21st date by our data. You can use that to train, and you have to predict rest of the days, like after 21st to end of the month. You have to predict the hourly count for that data set.
Okay, so where is data, Janmajay? Where they can download the data? So
It's
in the
in the
this
data.
data,
If you scroll down, down.
yeah.
Yeah,
So
here
here
is
it
the
is
data.
available, right? Yeah.
Yeah, this is a sample submission. Your submission should be in this format, the sample
This
sub.csv.
test and train.
Yeah, train you should use to train the data set, and you have to predict the count for this test.csv. Out of that count, you have to create this sample submission.csv. Sir, if you can click on the sample submission.
Sample submission.
So your final output should be something like this: a date time column and a count column, which shows the date per hour and the count of that hour. So this should be your format of submission.
Okay, so what? Let me explain this. I mean, so train will have a, this data set will have a label, okay. So label is what? Count, okay. So if you see here you see the day, DT day, season, year, month, okay. And what are other column here? If you scroll this, holiday, just column, let's see, just columns, okay. So this is saying the day, season, year, month, hours, holiday, weekday, weather list, and temperature. Where is count?
Sir, if you scroll up a little bit, there are 10 out of 14 columns. You have to select 14 out of 14 columns. The right,
Here, okay.
yeah. Select all.
Yeah, so there are 14 column in this, and last column is a count, right? So you have, this is your label, okay. So you have to predict this, and this is having a 13 column test. So test, you have to predict for test actually by training your algorithm. So here, let me again do the 13 column. Okay, so 13 column. So you have to use this data and predict. Okay, when you predict, what you will get? You will get the count. Okay, right? And this count, you will have to, then you have to create one CSV file which will contain two column. One is date time and another one is count, which is you predicted, right? For this date time, what you have predicted, CNT. So you have to create a detail like this, okay? And you have to upload this file. Where you will upload, I will show you. So this, when you upload this file, it will rate your performance. Okay. So I'll show you where to upload, but this needs to be created like this. So this date and time is where you will find this date and time, Janmajay. it is there in this or
Yeah, you have to do some column manipulation. This date day has a date column and hour has a time part of it. So you have to combine those two columns to generate the date time column.
yeah, or you can just send this function Janmajay, how they have to do. I think or you to try it. I mean, you will able to do it, but only thing is you have to read it, and how to do it. It is given in this documentation, I think, right, Janmajay?
No, I think it's a simple Google search. You can do that. How to combine column in the pandas.
Okay.
So that will be
Okay. If anyone finds the difficulty, contact
yeah, just
Janmajay. Okay. He
yeah,
will.
just
Yeah.
ping us. We'll help you out.
Okay, so that's how we need to. Then what you have to do, once you have this submission, first you have to download this train data set. You have to train your model. After training, you have to download the test. You have to predict the value, and out of the prediction, you have to create the sample sub CSV file, and then upload. Go to the leaderboard, and you have to upload the raw data. Okay, when you upload this, your name will come and your score will come. Okay, the lesser the, in this case, lesser the value, higher the score. But also this will give you the leaderboard, so your score will come up and down. I mean, so you'll see the your position based on that only. But the lower the score, higher the
So for this
output throughput.
particular competition, instead of measuring the accuracy, we are measuring the error. So the lower the error you get, you will be on the top of the leaderboard. So your goal is to minimize the error as much as you can possibly get.
Okay, so this, now what we have to do, what we have done here, I mean Janmajay has done, is basically you all have been randomly divided in a different teams. Okay, so so we have created 12 teams. Okay, so this is a team first, so name is given here. We will share this detail with you. Okay, so I think what we are thinking is, I mean, who I know all are not coming in the session, but at least one of the person will be there in that team. So I mean, who is active? So maybe one or two people, three people, four people. So based on this today's count, let me see how many are there. So I don't know. It is the count. 31 people are there. Okay, so at least two, three people will be there in each group, right? So that's what we thought, and you create your group. So how do we create your, you have to join the Kaggle competition. So we'll Janmajay will send the invitation to that, right, Janmajay?
I'll share the link. You just have to join the competition. You will see a team tab on top of that the competition page. So if you can go to the competition.
And you have to create a team also. You first, so you have to explain it, Janmajay, how to do it.
So
Maybe
sir,
you
can you?
can do the Monday. So what I will do?
I'll share a document with everyone like how to join the competition and how to create a
Yeah.
team on Kaggle and everything. I'll share it.
Okay, so Janmajay will share that. So you will be able to create your team, and uh, this competitions you will see then. Okay. So where is our Argosoft? So that's all, I think. This, it should be visible here, right? Huh?
So, if you can scroll down in your right side panel.
Right side, oh, yeah, below. Okay, your work. Okay. All right.
Yeah, yeah.
So here you will get, let's say some will search something. So once Janmajay will send that link, you go here and some search, then we'll see the competition here, and let's say this is the competition. Then it says join competition. From here you have to join the competition. Okay, once you join, then you are able to create then we are here. in this bike renting. So you will need to search for this bike rent. What is the name? Yeah, this is okay. So also, if you try, you will be able to do it. Home, and here you'll see like this. Maybe if it is not public, you might not be able to see it, but I think it must be there. Then you click here, then you will see the join button. I don't see because I've already done it. Anybody are doing it? Then let me know. So I have to send that name of the. Let me send that name here.